Hello, my name is Sara Perez Soler, and I'm going to introduce our work called Towards Automating the Synthesis of Chatbot for Conversational Model Query. I have divided the presentation in these sections. First, I'm going to explain what is a chatbot and how does it work. I'm going to continue with the motivation of this work, then a proposal which includes approach and a prototype, and finally conclusion and future work. Then, what is a chatbot? A chatbot is a software application that interacts with the user via natural language. Chatbots have proven useful in various contexts to automate tasks and improve the user experience, such as automated customer services or education. It can be integrated with social networks, in web pages, or even in speakers like Google Home. In recent years, the use of chatbot has dramatically increased. How do chatbots work? Well, there is many types of chatbots, but we have generalized a chatbot workflow. When a user sends a message to the chatbot, it tries to match the message with an intent or intention. Here we have some examples. If the user says, hello, his intention is to greet, and if the user says, I need to fly from Madrid to Paris on Wednesday at 9 a.m., his intention is to book a flight. Some intents may need to do action in external services, like book a flight, issue send a request to an airline service. The external service calls may require parameters to process the request. These parameters can be obtained from the sentence. In the book a flight example, the chatbot obtained the parameters from with the value Madrid, to with the value Paris, and when with the value Wednesday at 9 a.m. Entities are the type of the parameters. There are predefined entities like date, text, or number, but domain entities can be defined for each chatbot. For example, the city entity, which lists the cities to travel. All parameters must have an entity type. From and to entity is city, and when entity is date. To motivate this work, suppose a city hall would like to provide open access to its real-time traffic information system. With the growth of the open data movement, this is a common scenario in many cities. This data is divided into, first, a static part of the information like city, district, streets, and their speed limit. And then a dynamic part, updated in real time, like the traffic intensity in the street or possible incidents. In this scenario, it could be useful if citizens with no technical background could query this information. But the problem is, if you want to consult a dynamic model, you can use the UCL or similar model query language or predefined queries, which may not be flexible. And these methods are not accessible to end users with no technical background. So, we propose the use of chatbots to support conversational queries over the models. But designing and programming chatbots is a time-consuming process. However, we can use the ability of the metamodel describing the structure of the models to automate generation of chatbot supporting queries over models. To do that, we define this approach. First, a chatbot designer needs to provide a domain metamodel defining the structure of the model to be queried. It is necessary to complement the metamodel with a natural language configuration, which provides synonyms to refer the classes and features. Using the domain metamodel and the natural language configuration, executable chatbot models that can be used to query model instance is generated. The generated chatbot contains two models. First, the intents model, which contains the definition of intents and entities. And then the execution model, which defines the action that the chatbot can do. For each intent defined, there is a corresponding action. Now I'm going to explain a little bit the entities and intents definition. The model generator defines an entity with the name class, which contains one entry for each class in the metamodel. and use the natural language configuration to add synonyms to the entries. Here we have an example of the previous traffic system meta model. Also, it generates an entity for each attribute type. Using the traffic system, it generates two entities, one for string attributes and other for numeric attributes, and add the entries from the corresponding attributes. In addition, an entity operator is generated for each attribute type entity. A string operator contains the operation that we can do with the string attributes. For example, start with or contains. And numeric operators like greater than or equals. The last entity defined is the entity condition. It is a composite entity made up of the attributes and comparators entities. This entity allows the chatbot to identify and understand expressions like name start with ma or injuries greater than 1. Finally, the chatbot generator defines one intent for each query type and one intent to load the model from a location. The generator populates the intent with training phrases and defines the parameters and the required parameters. The first training phrases of all instances is give me all the class name, where class name is a parameter with the entity class. And it requires the model parameter of load model intent. The model parameter is necessary to locate the model to query. This intent will be matched when the user says, for example, give me all cities. The intent filtered all instance is similar to all instance, but it has a filter parameter in the training phrases. The type of the filter is entity condition, and it will match when the user says, for example, show me all accidents with more than one injury. The execution model defines the behavior of the intents. It defines a set of rules, one per intent, and uses the parameters to build an OCL-like query to collect a set of objects the user wants to retrieve. Here we have a rule example of all instant intent. The first two lines in the rule gets the class name parameter value from the contents variable, available in every execution rule, and pass it to EMF platform, which performs the query. Then the last two lines obtain the results from the EMF platform and answer the users with them. In the last step in the general approach, a chatbot execution platform executes the chatbot models, and the users can use the chatbot via natural language message in social network to query a model instance. As a proof of concept, we have created a prototype. This prototype divides the approach in two parts. First, we have created a chatbot generator to generate a ChatKit chatbot. Then, the ChatKit platform executes the chatbot to interact with the users. The chatbot generator consists in a web-based environment supporting uploading the domain metamodel in a query format, fine-tuning the natural language configuration, and automatic synthesis of ChatKit chatbot model. This is how the chatbot generator looks like, with the previous traffic metamodel uploaded. For each class and feature, we can add description and synonyms. And then we should click on Generate to create a ChatKit chatbot. ChatKit is a tool which uses model-driven techniques to define and execute chatbots. It provides a DSL to define intents and actions. The actions are defined via a platform that normally interacts with external services. To do this prototype, we have developed a new ChatKit EMF platform that allows queries the models and responds to the matched intents. On the left, we can see how looks the ChatKit chatbot generated from the traffic metamodel. In the image, we can see two users' interaction. First, the user loads the model, and then sends the query, give me all the incidents with more than 2 injuries. And the chatbot sends back a table with the information requested. To conclude, conversational interfaces are becoming increasingly popular to access services, but their construction is challenging. We propose using chatbots to conversational queries over the models. To facilitate the chatbot creation, we profit from a domain meta model to generate the chatbot to query the instance. We have created a prototype for our proposal that produces ChatKit-based chatbots. In future work, we plan to improve the bot generator to add more complex queries, to extend our approach to query other type of data source, for example databases, and to add access control on the bot definition to ensure users cannot explore part of the model unless they have permissions. Thank you for your attention.